Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a new topic regarding the methods of dimensional analysis. In our last lecture, already have discussed regarding the dimensional analysis, but in this lecture, we'll discuss the methods of dimensional analysis. Actually, if the number of variables involved in the physical phenomenon, if it is given or if it is known, then the relation among the variables can be determined. And how we can determine the number of variables or the relation between the variables, that can be determined by two methods. First one is Rayleigh method. First one is Rayleigh method, and second one is Buckingham pi theorem. Actually, second one is Buckingham's pi theorem. So these are the two methods where we can identify the relation between the number of variables when a physical expressions are given or it is known. Then we can see that what are the variables are involved in that and what are the relation between the variables. So in this lecture, we'll discuss regarding the first one, the Rayleigh method actually. So this lecture will discuss about the Rayleigh method. Actually, this method actually used for determining the expressions for the variables. Okay, where maximum 3 to 4 variables only given. Where 3 to 4 variables are there, only for particular that point we can use this method. 3 to 4 variables. If it is more than 4 variables are given, then it is very difficult to find out the expressions, what are the dependent variables are there, difficult to find out. So maximum 3 to 4 variables are there, we can find out the expression between them. So now let me give you some examples or some constants or some for better understanding, so that you'll get more idea about this, what is this Rayleigh method. Okay, let's consider, suppose x is the variable. Okay, suppose x is the variable, and this variable actually which depends on number of variables. Okay, number of variables, what we can say, if I consider x is a variable and that depends, suppose like x1 is there. Okay, similarly x2 I can take, and similarly one more variable, let's consider x3. So these are the another some variables are there. These are the some another variables. So according to the Rayleigh method, what is said, the x is a function of x1, x2, x3. Okay, so what we can write here, that as I told you, here we can write this x equal to, we can write it is a, as I told you, this is a function of here x1 comma x2 comma x3. See, x is a variable and these are some other variables are there. So x is a function of x1, x2, x3. Or the same expression we can write in other terms like x equal to k into x1 to the power a into x2 to the power b into x3 to the power c. Actually here, why I have written in this way, in these methods. So here I have taken the k is a constant. Here we have taken k is a constant term, and the ABC are the 3 different arbitrary powers which is involved with the variables. So here we can write ABC. These are the arbitrary powers. These are the arbitrary powers which is involved, or which is variables to the power, which powers are there. Now the value of ABC that can be obtained by comparing the power in the right hand side and in the left hand side. What is the power in this side and what is the power in this side? So that will be or can be identified by comparing the dimensions, in the both side. So to identify these values, we need to take some examples so that you can better understand. This is for just for mathematical expression what I expressed here. So now we'll take an example so for better understanding. So let's consider suppose, okay, so here let me write one example. Okay, so let power, we'll consider the power one expression. This expression for power for suppose pump, power for pump. Okay, so what is the questions will be given? The questions will be given in such a way that to find the expression for power which is developed by a pump. Okay, and when the power will be depends on variables, because see this is also a variable and the power also will be depends some other variables. So what are the other variables will be there? So the power of a pump will be depends some other variables like head and discharge and I can say some like specific weight. Okay, the questions will be given in this way and we need to find out the expressions for this. Now let me start for this. So as the question is given, like the power P is a function of, it is a function of, we can say it is a function of, we put the square bracket here. So this is a function of H, head, discharge and W. This is specific weight. Now the same equation as per what I have told you, that same thing I can write here in this manner, like P equal to K H to the power A and Q to the power B and W to the power C, and make this equation equation 1. And here K is the non-dimensional constant. As I told you previously, K is a constant, so this is a non-dimensional constant. Now what we need to do, we need to compare the dimensional or dimension for both the sides, left hand side and right hand side. So this is here, suppose this is our left hand side and this is our right hand side. Now we'll identify the dimensions for both the sides. So suppose first let's find out the power dimensions for the power. Power equal to, we know that this can be defined by work per time, and for work per time we can say work unit is, we can say joule, and the time unit is second, and joule also we can write again, this is Newton into meter, and this is second is there. Now again, if you want to just split this directly, you can write if you know the dimension of the power, or if you can follow the previous videos where we have discussed regarding the dimensions of several parameters. There we can identify. So now in this Newton also we can write again, this is kg, let me write kg into meter, kg meter into by second square, and into meter is there and divided by again second. And finally if you see what we can get for this, P equal to I can write kg, the numerator meter into meter is there, so meter square, and in the denominator this is second into second square, so second cube. Now let me write in the form of dimensions. Kg, this is these are we need to represent in the fundamental units. So fundamental units is 3 are there: mass, length and time. So kg, mass I can write m, and what about the meter square, that is length, so L to the power 2, and this is second time in terms of t we can write, and t to the power 3. The denominator when it will come to the numerator, it will represented in this. So this is the dimensional form of a power. Now we'll come to the right hand side. Okay, so for this let me draw a line here, so that we'll start from here, then we'll go to the other side. Now for the right hand side, first one, head. So head is nothing but this is the distance, actually some length is there in the pump. So head, some length as I told that we can represent in terms of L. And similarly, Q is the discharge. So discharge is nothing but we know that what is the volume of water is coming out with respect to time. So we know that this is meter cube per second. And here also meter cube means length, width and height will be there. So similarly, we can write LQ by T. If you represent in terms of dimension, so we can write L3 and T to the power minus 1. So this is about the discharge. Now the last one is there. This is here W. This is specific weight actually. So the specific weight we can write actually specific weight equal to, we can write weight per volume actually. This is weight per volume. So weight per volume we can write, this is the unit we can write Newton per meter cube. Okay, and Newton per meter cube, just now we have identified Newton equal to kg meter into centimeters second square. So that one we can write in the term like kg into meter per second square, and this is meter cube is there. Now if you see this, so what will get here, meter will be cancelled, and only one like 2 meters here, meter square will be there. And if I represent this one, so W equal to, I can write kg m, and this is meter square, that means length. So length L to the power minus 2 and T to the power minus 2. Okay, so this is the dimension analysis for all these variables. What are the variables? H, Q and W. Now what we need to do, we need to equate both sides as I told you as per the equation 1. So now equate all these dimensions in both sides. So what dimension we got for the power? So this is power m, L to the power 2 and T to the power minus 3. Okay, and equal to this equal to first one here k. We can write, this is actually we can write in this way, k is the non-dimensional number. We can write m to the power 0, L to the power 0 and T to the power 0, or else we can omit that one also, and directly we can write this value k only. And first one h to the power a. So here we can write k L to the power h. Okay, and now next one is q. You got what? Here we can write L to the power 3 and T to the power minus 1 and to the power b, because the power is there, that arbitrary power is there b, so we need to present that. And next one is that is next value is W, specific weight. So here also you need to write m, L to the power minus 2 and T to the power minus 2 whole to the power c. So this is another one, arbitrary power. Now we need to compare this left hand side and right hand side. Okay, what we need to compare? Now we need to compare mass with mass, length with length and time with time. So by comparing of these two, okay, what will get? So for the mass we'll get this side, what is the mass is there, and what are the mass value in the right hand side. So this side if you see, the mass value is here 1 is like to the power 1 is there, and in the right hand side if you see, here mass is not there, here not there, and here mass to the power 1, that is c. So we can write only c. We can write only c. So what we are what we got here, what is the value of c here? We got the value of c is 1. So we can give the equation 2. Now similarly compare this dimension analysis for length. So dimension analysis length is, this side is 2 is there, so let's write 2 equal to, here length is how much? 1 is there, so 1 to the power this a is there, so 1 into a, this is a. And next is L to the power 3 is there, and here b is there, so plus, here you can write plus 3b. And the last one if you see, minus 2 and c is there, so again same thing we can write here, minus 2c, just to multiply these variables, ratio of variables and arbitrary powers. Now this one we can give equation 3. Similarly the dimension analysis for t, time is there. Here if you see, minus 3 value is there, so you can write minus 3 equal to What about this right hand side? Here now value is there. So now t to the power minus 1 into b. So you can write here minus b. Okay. And in the next one, you can see t to the power minus 2 and c. So this one also you can see minus 2c. And this one equation 4. So what we got here, we have identified all these values of mass, length and t in terms of variables. So now what are the value we got here? See, c value 1 we got. Now we need to find out each values. Okay, like a, b, c value. Okay, here if you see already c equal to 1 we got here. So you can just highlight this, c equal to 1 we got. Now in these two equations, if you see which is more reliable, we can put the value of c and we can identify the another one variable. So if you see the equation 4, here b and c are there, so put the value of c in this equation 4, and here we can find out minus 3 equal to minus b minus 2 into 1. Now if you solve this one, I think we can get the value this side 2 and this minus value, take it to this side, so positive. So we'll get b equal to finally 1. B equal to 1 will get. Now see, c equal to 1, b equal to 1, and put this all these two values in the equation 3. Then let me draw another one line here. Yeah. Now finally put all these values of c and b in the equation 3. So what is the equation is there? 2 equal to a is unknown, let's keep it a, plus 3 into 1 minus 2 into 1. So if you see 2, a is keep this side, and 3 into 1 3 minus 2 into 1 2, so 3 minus 2 1. Take this one into the left hand side, so 2 minus 1 equal to a. So finally what we can get here, a equal to 1. So all this a, b, c value, what we got here, 1 1 1. Now what we need to do, we need to just put this value of these variables in the where this power values, a, b, c power values in the variables, where we got the variables. Now these are the variables what we got in the equation 1 actually. So now again go back to the equation 1, and finally we can write p equal to, you can write p equal to k and h to the power 1, and this is q to the power 1 and w to the power 1. And if you see that to the power 1 is nothing but no values will be there. So finally we can write this is p equal to, and this constant value also by doing the number of experiments we can find out the value of constant, and that also sometimes they used to say this value of constant k equal to 1 also they have identified, or else we can keep this value k equal to k into h into q into w, or sometimes they used to write p equal to h, q and w. So this is the final correlations. So this is one method, as I told you, this is one method, that is ReLEG method, okay, where 3 to 4 variables are given and we can identify the correlations between them by seeing this. So this problem what I have taken here, only 3 variables are there. In the next lecture, in the next problem, we'll see when it is 4 variables are given, then how to solve that one. That is slightly different than this one. So I hope this lecture you have understood everything. If still you are having doubt regarding this concept, you can give a comment on the comment box. Thank you all.